triangle DEF. Now, you do want to pay attention to what it's asking for. It's asking for the measure of angle E. It's not asking which angle E is congruent to. So you really have to be careful about what the question is asking. It's asking for what it equals, not what it's congruent to. All right? So angle E is listed second, and angle B is listed second. So we know because they're similar polygons, their angles are congruent. So angle E is congruent to angle B. I've talked way too long about such an easy problem. It's 52 degrees. 52, because I checked angle B. Angle F is yet to be determined. We will use good old triangle sum theorem. Subtract those from 180, and the remaining degrees in the triangle is 23 degrees. EF, that means the distance from E to F, the length of segment EF. EF is right here. It is proportional to BC. Remember, when two triangles are similar, their angles are congruent and their sides are proportional. So I could set up a proportion appropriately, and I could say 6 is to 4, as I could call this X, or I could call it EF, is to 10. So I did circle is to circle as underline is to underline. Or you can find the scale factor, and you can use scale factor when you go to the larger shape, you'd use the improper fraction, and when you go smaller, you'd multiply by the other fraction. You're going to get 15. To find AC, you can set up the same proportion. 6 is to 4 as 12 is to, I'll call it Y. And you will get 8. All right? Get to that, Pavan. All right, so the next portion, I have scale factor 9/2. X is 13.5 or 27 halves. 6, 2, 7 over 5, and 25. Any questions about those? Remember, scale factor second over first, so we did 18 over 4. That's how we got 9/2. Second over first, 14 over 10. And that's how we got 7/5. All right, I'm going to keep going. I was asked if you will have to justify on the test. There will not be a justify box, but by putting that box there, that makes you think, oh, did I really check to see if the sides were proportional, or did I just see a side with an angle in between with another side? You know what I mean? It just helps hold you accountable. No, there will not be a justify box on your test. Oh, I'm dropping markers. Number 6, I got side, angle, side. A, B, C. And the reason is because 8/32 is equivalent to 13.75 over 55. And angle R is congruent to angle A. So that's why it's side, angle, side. Number 7, none or not similar. The reason is 6 over 11 is not equal to 7 over 14. So it would have been side, angle, side had those sides been proportional. Do you have to check? Absolutely, you have to check. Not all right triangles are similar, right? That was on your homework. Not all right triangles are similar. Okay. Next one, this one's of course angle, angle. SPT. And the justification is that it's this angle right here. That's the reflexive property of equality, and then the other angle is already marked. I'm not going to write the long angle names in the box, but that's where the angle, angle comes from. You can add an arc to P. This one you've seen multiple times. You've seen this picture. Side, angle, side, not similar or none. And this one, the sides are proportional. How do you know on number 11 which sides to match up? How do you know? Small over small, Medium over medium, large over large. Yeah, that's how, we don't have any angles to go by, so you just pick the smallest one. It goes with the smallest. The medium goes with the medium, and then the leftover ones. Okay? And you set up a proportion. Yep. All right, on the back. All right, 19.2, we're going with it. Cool. Find the missing side, then calculate the perimeter. All right, on the next one, you can do the same thing. You can do inches is 2 miles as inches is 2 miles, and cross multiply. Remember, when you are setting up a proportion, when you're cross multiplying, you never have to convert the units. You never have to convert them units because the inches will cancel and your answer will be left beautifully in miles. All right? 3/4 times 2 divided by 1/2. 3 miles. 14. On a blueprint, 1 inch represents 8 feet. 1 inch represents 8 feet. If the height of the wall is 1.5 inches, what is the height of the real wall in the real building? So we cross multiply that and we get 12. I'm not worried about you doing that. I'm worried about you getting the correct scale factor. So just a reminder, when you're getting scale factor, especially in a problem that has units involved, when you're doing a scale factor, you put second over first, and then you make the units match. There is no such thing as reducing when the units are different. The units have to match to reduce your fraction. And I know you're not really reducing this one because it's over the number 1, but you get what I mean. 8 times 12, 96 over 1. The inches cancel. We wanted the inches to cancel because scale factors don't have units. Okay? Let's work number 15 because I have a sneaking suspicion that you'll see this one again. A 6-foot-tall Lewis. All right, let's draw a Lewis. 6 foot tall. Oh, I'm using the color I don't like to use anymore. Okay. 6-foot-tall Lewis is standing 12 feet away from the base of a tree. He's shorter than the tree, so I need to be careful. I need to draw a tree. It needs to be taller than Lewis. Here's my ground. He's standing 12 feet away from the tree. He casts a 3.5 foot shadow. This is going to be my sun. Oh, that's a bad sun. Looks like flour. We did this one in our notes, I remember. So his shadow is 3.5, like this. If their shadows end at the same point, how tall is the tree? So we really have a triangle inside a triangle. They're similar because of angle, just trust me. And we need to find the height of the tree. So we're going to set up a proportion. This is why I don't teach art. No, just kidding. All right, so if I could say 6 is to x as 3.5 is to, here's the zinger, don't say 12. Good, you add them together. 15.5, very important that you get that denominator correct. So what was hard about this problem? Drawing the picture was hard, and making sure you set up the proportion correctly was hard. The cross multiplying is not hard. The remembering to put your answer with units is not hard. So yeah, if we round it, we're going to get 26.57, so we'll round it to 26.6. Okay? It totally depends on what the problem tells you to round to on the test. Number 16, I'm getting 6.75. So they're 6 feet tall. I like to do height over height equals shadow over shadow. So this person's height is 6 feet. The other person's height is 4.5. Do you get where that came from? 4 feet, 6 inches. Well, 6 is half of 12. So it's 4.5. Okay, Aaliyah, I get you. I get you. And this would be x. And it's all feet. It's all feet, 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 feet. So you cross multiply, you get 6.75, or like you were saying, 6 feet 9 inches. That's a good point. On 17, I got 6,347.8 yards, or 3.6 miles. It didn't really say what to put our answer in, yards or miles. Now, when you cross multiply, your answer ends up in yards, so I promise you won't have to do that conversion on the test. You won't need to convert. They're both right answers, though. So if I call this x, we could say 2,000 is to x, as 2.3 is to 7.3. That 7.3 is the important part. You have to add 5 to 2.3. Okay? On the first one, good. X is 13. On the next one, X is 8. And Y is 10/3, I believe. Yes? And on number 20, X is 14/3, and Y, 13 is to Y as 7 is to 9. You might have ugly fractions on your test, just warning. 13 times 9 divided by 7, ugly answer, math, enter, enter. 117/7. Okay, guys, 21, big deal right here. 21, like I just said, is a big deal. We drew the picture for you. You're welcome. We drew the picture. But the problem is, I don't see any triangles. I see 0 triangles in this picture. So we have to be really careful. Let's label what we know. We know a person whose eyes are 5 feet from the ground. So we know this guy who honestly looks like he's picking his nose. It's kind of weird. Anyways, maybe he's just doing this. Anyways, this guy is 5 feet tall, or his eyes are 5 feet off the ground, and he's looking up. He's looking up to the top of a pole, and his line of sight also goes to the top of the building. He knows, somehow he knows that the pole is 25 feet tall. His feet are 30 feet from the base of the pole, and the pole is 90 feet from the base of the building. These are all feet. What is the height of the building? We cannot set up a proportion. You can't just assume trapezoid sides are proportional. You have to have triangles. We only know how to prove triangles guilty of being similar. We didn't learn how to prove any other shapes. So here's the trick. Is everyone looking at the trick? I'm going to be sneaky. I'm going to turn lemons into lemonade. I'm going to turn something that doesn't have triangles into something that does have triangles. So I'm going to take this, I'm going to go, yes, you must do the sound effect. Yes, you must. All right. Now I have triangles, except all that information, does it translate or does it not translate? Now, what is this value right here? It was 25, but his height is 5, so subtract 5 from it, so that is now 20. I'm going to call this y. From here to here is going to be y. And then guess what? Those numbers from the bottom, they just transfer directly up. We don't need to worry about those. 30 and 90. Cool. Can you add 5 feet to 30 feet? I'm not sure. I wouldn't add the 5 and the 30. All right, anyways, so now we have our new triangle. So I can say 20 is to y as 30 is to, do you see what I'm doing here? 20 is to y as 30 is to, you better grab that whole side, 120. Don't say 90 because we need the whole side that goes along with side y. Are we okay with this? We will cross multiply 120 times 20 divided by 30, and we get y is 80. We didn't just want to know what y was, we wanted to know what x was. So we could take this value and slide it over here. This was 5. We just found out this is 80. So what's the height of the building? It's an 85-foot tall building. So, not a difficult problem, but a tricky problem. Now you know the trick. All right?